For today's lesson, I decided to attach my own notes to kind of help in any way I can do so. So today's lesson is called the Mean Absolute Deviation, or MAD. Okay, there's some key vocabulary up here that you should know already. Last week we talked about the mean, which is the average. You add up this to get the sum of all data values and divide by the number of data values you added up, and that gives you the mean. Deviation, the difference between a data value in a set and the mean. Absolute value we've talked about in the past as the distance from zero. For instance, negative 15 has an absolute value of 15. It's 15 spots away from zero. Positive 15 would also have an absolute value of 15 because it's 15 spots away from zero as well. Okay, when we're talking about absolute value today, we're going to be talking about the distance each data value is from the mean. Variability, we'll talk a little bit more. Basically, it's how spread out that the values in a set are. Okay, here's some definitions you can look over or some notes I wrote for you. So today we're going to look at the difference between Sherlock's data set and Watson's data set. So over here, we're going to focus on Sherlock first. So here's Sherlock's data set written in blue. His data values are 92, 83, 88, 94, 91, 85, 89, and 90. So to find the mean of those values, we're going to add them up, and there are 8 of them. So then we're going to divide by 8. Add up to get the sum, divide by 8, and the mean is 89. Now we're going to find the difference between each data value and the mean. So the first data value here is 92, and we're going to subtract the mean of 89. 92 minus 89 is 3. The second data value is 83. 83 minus 89 is negative 6. The third data value is 88 minus 89, which is a negative 1. And then you're going to do the remaining of the total of 8 data values. So now once you have those positive and negative data values, you're going to find the absolute value of each of those. So up here, the absolute value of 3 is 3. The absolute value of negative 6 is 6. The absolute value of negative 1 is 1, and so on. Find the absolute value of all 8 data values. Then down here, you're going to take those absolute values and find the mean of them. So again, there should be 8 of them. Divide by the number 8, and we have a mean of 2 and 75 hundredths. So that's your mean absolute deviation. So the average distance between each data value and the mean is 2 and 75 hundredths. So the MAD is very small. It implies that the mean, which is 89, is indicative of the other values. Okay? So that means that the data values are clustered together very closely. So now if we come up to Watson up here, he again has 8 data values up here. Take the 8 data values, divide by 8, and you have a mean of 79. Again, you're going to find the difference between each of the 8 data values and the mean, which is 79. But you're going to notice all the numbers are pretty close together there, except this number 5. That's what we're going to call our outlier. Okay? It's a number that's not close to the rest of them. So let's say you're a 90 student. You get a 92, a 94, 98, 96 on your test. Maybe you're sick one day, and all of a sudden you get a 20. That would be considered an outlier. It's not a typical score. Okay, so again down here, absolute values of each of those data values. The mean absolute deviation is 18 and 5/10. That's your mean absolute deviation. That's very large. That implies it's not a reliable indicator. Okay, that's because of that outlier 5 there. Your information is going to be very widely scattered. Okay,